Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 567, permutation in string. This is a medium difficulty Leetcode problem. And in the problem description, we're told that given two strings, string 1 and string 2, we want to return true if string 2 contains a permutation of string 1 or false otherwise. So in other words, we just want to return true if one of string 1's permutation is in the substring of string 2. A fairly simple problem description. As far as problem descriptions on Leetcode actually go, because sometimes it can be quite complicated. And we're given two very nice examples, very simple to understand. And, in this example, the permutation, string 2 contains one permutation of string 1, which is BA, and we can see that here, and string 1 is AB. And in this second example, there is no permutation, so we just return false. So what kind of problem and what kind of problem is this? Well, this is a sliding window problem, and it is a bit difficult to spot, as most sliding window problems are, and I say this every time. But once you figure that out, it's quite simple. The logic and the intuition behind solving this is also quite simple. We want to go through each character in our string and add it to a dictionary. Let's just say this is a dictionary, and then we have another dictionary, which was going to be the starting point dictionary. This is going to be the dictionary of all characters, a hash map of all characters, as well as their counts of string 1. And then as we're going through string 2, all we want to say is in our window, this fixed window that we have, we're going to create a dictionary from that. We're going to update this window as we go along, adding and removing characters from our dictionary, and we want to compare, and if they are equal to one another, then we've found a permutation, and if they aren't, then we'll move on to the next window. So let's actually get to coding this up. The first thing we want to do is just check for an edge case. We don't have to, because our for loop won't actually run, but we can just say if the length of string 1 is greater than the length of string 2, well, there's no way we can actually find any permutation, so we're just going to return false. That's that out of the way. And the next thing we want to do is create a dictionary for string 1, just create an empty dictionary, and say for each character in string 1, let's increment the count for that character. So C equals dot get C and 0. And what we're going to do here is basically say, if using the get method, if there is no value for this, we're going to initialize it to 0 and then increment it by 1. The next thing we want to do is create a dictionary to store our window. So we have a dictionary for our string 1, and then we want a dictionary for our window itself. So what we're going to do is we say window dictionary, and then we want to have a window size, which is going to be equal to the length of string 1. And we want to say for each character now this is the part that I have to think a bit. Okay, string 2 up to the window size. What we're doing here is basically creating the initial state for our window. We're just initializing our window with the values for its initial state. And we can just copy this line over here and replace window dict. Okay, so that's our window created. And then we can simply say if window dict is equal to our string 1 dictionary, well, then we've found a window. We don't need to do any more processing. We can simply return true. If that's not the case, though, we want to actually go through our entire string 2 with a window and find any permutations. So we're going to say for I in range, pass in window size up to the length of string 2, and we want to say let's increment the count in our window dictionary. So window dictionary si going to increment that by 1. So we're basically going through and adding as well as removing any values which now fall outside of our dictionary because we've shifted our left pointer, which is inferred from our I value over here. So SI minus, actually no, we can just say SI minus window size, can't we? So SI minus window size minus equals 1. And something that we want to remember is we're not initializing string 1 dictionary with zeros for all of the values. So we want to say if this value is equal to 0, we want to just delete it. We're just going to say delete. There you go, you're deleted now. And then if window dictionary is equal to, and actually I can just copy this over here, we're now going to check and compare the dictionaries. If they are both the same, we're just going to return true. Otherwise, we're going to return false. And then submit our code. And okay, that needs to be S2, 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 S2. Oh gosh. That's what happens when you make a typo and you don't actually name variables correctly. There we go. So we've passed all 110 cases for this problem. For the time complexity, it's going to be a big O of n. Time complexity, space complexity is going to be a big O of 1. You know, it would actually be a big O of 26 because of all the letters in the alphabet, but we can just simplify that down to big O of 1. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.